To continue to go ahead and solve equations. Now, some of these equations can only be solved using logarithms unless you want to use guess and check, which can take an awful long time. Now, one of the things that's going to help us is using the log button on your calculator. But your log button on your calculator does not handle something like this here, which is log base 4. Your calculator only handles log base 10. So, see if you can see what are we doing to go from this to this here, or what are we doing to go from this to this here. And looking at the color coding, you'll see that the log of the bigger font size right here is what goes on top. The log of the smaller font size goes down here. So the big font size goes on top, the small font size goes on the bottom. And now you'll notice over here in these fractions that there's no base written. That's assumed to be base 10. It's referred to as your common log. So if you see log of x with no base, that means the same thing as log base 10 of an x. So what we're talking about here to begin with is really your change of base formula, which is here. You can technically change it into any base you wanted. But since your calculator uses base 10, typically we're going to be just using this right here. Once again, you do log of the bigger font size on top divided by the log of the smaller font size on the bottom. So we're going to go ahead and rewrite each one of these using our common log, so we can go ahead and type it into our calculator. Once again, we need to go log of the bigger font size, this, put it on top. Log of your base, which is down low, goes down low. You type it into your calculator, you go hit your log button on your calculator, then you type in 20, close your parenthesis, then hit divide, go log of 4, close your parenthesis. You type it into your handy dandy calculator, and when you do that all at once, you get about 2.161. And you'll notice our direction said to the nearest thousandth, so that's 3 decimal points. Our next one, we're going to go ahead and do the same thing. Using our change of base formula, you take the log of the bigger font size, put it on top. Log of the smaller font size goes down on the bottom. Then you want to go ahead and type that into your calculator. You'd hit your log button, type in 3.904, close your parenthesis, divide log 4, close your parenthesis, and when you do that, you get about 0.982. Now, you will notice over here that there's no base written. It's already base 10, so we don't have to do change of base formula. We can just type into our calculator log of 32 because it's already base 10 and common log, which your calculator can handle and likes to handle. If it was a different base other than base 10, and once again it's base 10 because there's no base written, then you'd have to go ahead and use your change of base formula. Now, we'd already talked about this before, but just remember that if there's no base written right here, it's assumed to be base 10. Or if it is written with base 10, you can write it as just a log with no base. Now, we're going to use this to help us to solve these equations down below. Now, you'll notice that we have here 16 to the power is equal to 90. This is the exponential form. We could go ahead and rewrite this in the log form using our definition of a logarithm. We would go log of our base, which is the 16. Your exponent here goes on the other side all by itself. What was on the other side all by itself goes after your log. Now, this is log base 16. Remember, your calculator only uses log base 10, so we have to use our change of base formula. So we have to then go log of the 90 over the log of your base, which is the 16, And this is what we refer to as your calculator ready form. You can type it into your calculator just as you see it. You go log 90, close your parentheses, divide log 16, and when you type that into your handy dandy calculator, we would get this. Notice it said to the nearest 10,000, so that means 4 decimal points. We're going to do the same type of thing on this next problem. It's 15 to a power is equal to 93. So I'm going to go and change it into a definition of a logarithm, or go from the exponential form to a logarithmic form using my definition of a logarithm. Here's my base, the 15. Remember, the exponent goes on the other side all by itself. What was on the other side all by itself goes after your log. Then we have to go ahead and use our definition of a logarithm, or not definition, change a base formula, and we have to go log of that 92 divided by log of the 15. So now you can take what you have here on the left, log 92, close your parenthesis, divide log 15, close your parenthesis, hit enter, and then because we need to try to get n by itself, we divide by 3. So after you get that nice long decimal on your calculator, now just hit divide by 3. When you just hit divide by 3, you can get this. Now, another thing that you could have done is you could have just divided by 3, and you would have had log of 92 divided by 3 log of 15. When you type this in, you'd still go log 92, close your parenthesis, divide, but because you have more than one thing in the bottom, you'd have to go, after you divide, you'd have to go open parenthesis, 3 log 15, close your parenthesis, and then you could still get to this. It can be done either way. Now, our last two problems we did, it was just something to a power equaling a number. We don't have that here because we have this extra plus 4. So in other words, we'd have to undo that to try to get the part with the exponent by itself. So I'm going to subtract a 4 from both sides. Well, now that the part with the exponent is by itself, we can go ahead and just use our definition of a logarithm, and we can write log base 5 of that 78 is equal to an a plus 7.1. Then we can go ahead and use our change of base formula here. We can go log of the 78 divided by the log of the 5 is equal to our a plus 7.1, and then to get a totally by itself, all we'd have to do is subtract that 7.1 from both sides. So it's our log fraction minus a 7.1. This is what we would refer to as your calculator ready form. So we're going to type this in by going log 78, close your parenthesis, divide log 5, close your parenthesis, minus 7.1, and then when we type that in, we would get a to be approximately negative 4.3930. We do need to have that 0 there because it indicated in the directions to the nearest 10,000. So we have to have that 0 there to indicate we went to the nearest 10,000. On the next problem here, once again, we need to get the part with the exponent on one side by itself before we use our definition of a logarithm. So that means we need to go ahead and undo our timesing by 5, so that means we'd have to divide both sides by 5. And then when we divide by 5, it ends up being a nice neat number over there, which is 2.4. If you wanted, you could have left it just as a fraction of 12 over 5. Now we can use our definition of a logarithm. Go log of our base of 11 of that 2.4 is equal to our a minus 6. Use our change of base formula on the left side. Log of that 2.4 over log of 11 is equal to an a minus 6. Then to get a by itself, we'd have to go ahead and add 6 to both sides. So we're going to have that log fraction with a plus 6. And then we can just type it in just as we see it. Go log 2.4, close your parenthesis, divide log 11, close your parenthesis, plus 6. Type it in all at once, and then you get a to be about 6.3651 when you go to the nearest 10 thousandths, which is 4 decimal points. So now we have another problem to look at. Once again, you need to get the part with the exponent on one side by itself before you go ahead and use your definition of a logarithm. Right now we have a minus 5, so we have to undo that, so we'd have to add 5 to both sides. We get 2 to our power is equal then to 96. Since our part with the exponent is on one side by itself, we use our definition of a logarithm, go log of our base of our 96 is equal to our 6n plus 4. Then we can go ahead and change this in using our change of base formula, go log of the 96 or log of the 2. Then I'm going to go ahead and subtract the 4 from both sides. So I get log of 96 divided by log of 2 with a minus 4 is equal to 6n. Now, what I would do is I would go ahead and type in the left side of the equation, go log 96, close your parenthesis, divide by log 2, close your parenthesis, minus 4. It's going to give you a nice long decimal on your calculator. Then to get n by itself, you just have to go ahead and get rid of that times by 6. So once you get all that big long decimal on your calculator, just hit then divide by 6. When you do that, you get 0.4308 is equal to n.